But it can, if you've got a rock made of nothing but granite, I bet you were near a granitic terrain. If you've got a rock made of nothing but andesite, I bet you were right next to a big andesitic volcanic chain. But those are altered then at the source. Weathering at the source basically gets rid of unstable minerals and rock fragments. And that continues as you transport grains. They don't just go down the river. They go down, they're deposited. While they're being deposited, they weather some more. Then they're moved a little farther, they're deposited, they weather some more. And so depending on how they're transported and how far they're transported, the soft grains and the chemically unstable grains get destroyed. And then it depends on the depositional environment. If you're depositing things in a, say, if you're in a swamp in a tropical environment, you're not going to get many smectite clays because those are going to be altered to kaolinite because you're in a tropical environment. Okay, questions? Finally, after they're deposited and buried under the ground, the composition is changed further. You precipitate new cements, you dissolve some grains, you reprecipitate other things. And so there's a long history of change that doesn't end until you actually collect that sample. Because once, even after it's been uplifted, that rock is going to be on the surface being altered. Okay, so that's what clastic rocks are made of and how they get, and what shapes what you see in a hand specimen. Any questions? Anything to add, Kyle? I've got a great example of this today. We were sampling a rock in Colorado day before yesterday. And it was really weird looking. We couldn't figure out what was in it. It had these weird, odd-shaped white speckles all through it. And we whacked the rock and it just disintegrated because the diagenesis of whatever had deposited had turned it all. It obviously had been full of rock fragments, and unstable rock fragments at that. So and they'd obviously been altered by weathering and diagenesis to a lot of clay. And so it looked like a beautiful sandstone, but inside, all those grains had been turned to clays. So it was a weird rock. All right, questions? And I'm not going to spend much time on that. Feldspars the big things that get altered are feldspars and other chemically unstable grains. And that takes us to the next chunk of the lecture, which is classifying. And this is what you're going to do in the lab. You're going to learn how to describe and classify the rocks. And the way that we do terrigenous clastics is we start off with texture. And by texture, primarily, we mean grain size. And then you go to composition. So is it a conglomerate? Is it a sandstone? Is it a siltstone? Is it a mudstone? Is it a claystone? And so here I have a thing I put together that sort of guides you through your book has some other guides, and they use other words that we never actually really use in geology. So things like their paraconglomerate and orthoconglomerate, don't worry about that. Here are the basic things that you'll do is a gravel and we have different terms for soft sediment and then other terms for sedimentary rocks. So gravels and conglomerates are more than 80% gravel-sized material. Sand and sandstones are more than 70% sand-sized material. And muds and mudstones are have less than 30% gravel or 50% sand. In other words, if you've got sand and mud mixed, if it's more than 50% mud, it's a mudstone. If it's mud and gravel mixed, it's got to have less than 30% gravel. These are the end members. What do you think it is if it's a conglomerate that it's got, it's a conglomerate or mudstone or sandstone, and it's got 50% gravel-sized clasts in the material and 50% mud. What do you think you call it then? It's not a mudstone, has more than 30% gravel-sized material. It's not a conglomerate because it has less than 80% gravel-sized material. So it's
siltstone.
What are you saying, Andrea? No, go ahead.
Well, since the fee size is going to be more than 4 difference, it wouldn't be a conglomerate. Am I on the right track?
You're there. You're close. Actually, you're kind of, if it either is a conglomeratic mudstone or a muddy conglomerate.
Oh, goodness.
Same with if it's in between these with sand and conglomerate, it's a sandy conglomerate or a gravelly or conglomeratic sandstone. A pebbly sandstone. And to do that,
And that's science.
anyway, and so it's so all of this is pretty easy, but the trick is just going to be remembering the numbers of where we make the breaks. Okay, clays and silts are even easier. If it's got more than 50% mud, it's a mudstone. Doesn't matter. And then if most of that material, 2/3, is silt, then it's a siltstone. If more than 2/3 is clay, it's a claystone. And if it's a mixture, an about even mixture, more than 1/3 and less than 2/3 of the material, then it's a mudstone. So claystone, siltstone, and if they're mixed, it's a mudstone. Questions? Okay. And here's the numbers for what if it is in between. If you've got 30 to 80% gravel, so anything that's not a conglomerate and not a mudstone, then it's a muddy conglomerate. Same with the sand. If it's not a sandstone and it's not a conglomerate, then it's a sandy conglomerate. If they're just a few isolated fragments, then it's either a clay sand, silty sand, muddy sand.
Is that a real word?
Clayey?
Yeah,
Yeah.
it is. A clayey sand. It's full of clay, right?
Yeah.
Well,
No, they are real words.
That's awesome.
Anyway, so pretty easy, right? So please learn this. It's on I posted the lecture this morning, and I think it's more the actual classification scheme. I think is a little more straightforward than your book, because I think your book is really good for describing all this stuff, but then they bring in all these extra terms that are a little confusing. Okay. Questions? So what we'll do now is we'll go through each thing and go through sort of how you work through a more complete description in detail. And so, let's see, before I go on, anybody got